Hi, I'm Travis Leithhead, a program manager on the IE10 platform team, part of Windows. With Windows 8, you can build Metro-style apps using HTML5. One of the cool new features of HTML5 is web workers. Nobody likes a slow app, and I'd like you to understand how web workers can improve the responsiveness of your app and sites. Along the way, you should learn how to use web workers and when it is appropriate to do so. Responsive Metro-style apps and sites are more than just an extra feature. Responsiveness is an expectation. When your customers compare two apps side by side with the same basic features, the more responsive app will win the reviews every time. Web workers are part of the standards-based web platform and are a great tool for building responsive apps. The features and techniques that you learn here can be applied effectively to both Windows Metro-style apps written in HTML5, as well as websites in the browser. Let's take a look at an IE10 test drive demo that I'm building. This demo lets you build, the user become a stained glass artist. All the user has to do is draw lines across the frame, and the app automatically creates and detects when it should put a stained glass face in or subdivide it. You should notice that the app is having trouble keeping up with my mouse pointer. As I attempt to draw smooth lines, instead I get these jagged lines. This is not an ideal user experience because it makes the demo feel slow and non-responsive. Web workers can really help with the responsiveness of this demo. By checking this box, I program the demo to transition the detection and computation JavaScript algorithms into a web worker. Now you should be able to tell that the app is suddenly much more responsive. There's virtually no delay between the lines I'm creating and the mouse pointer position. As you saw in that demo, building responsive apps and sites can really affect the performance and the perception that your customers have of that performance. Customers expect apps and sites to be responsive and to load quickly. They don't want to wait for the app to perform long, complex algorithms or setup processing. When the app has started and is visible, they expect to be able to use the app immediately. As you saw in the demo, when this doesn't happen, it is noticeable and distracting. Customers expect your app or site to respond immediately to user input, be it mouse, keyboard, or touch interaction. As you saw in the demo, when this doesn't happen, it is noticeable and distracting. Finally, customers expect your app to stay responsive and never hang for long periods of time. So by now you have an idea of just how important it is to build a responsive app. Here are some important guidelines for doing so and some additional sessions you can check out. Metro-style apps and sites written in HTML5 are powered by the IE10 hardware-accelerated rendering engine and leading-edge JavaScript engine. It's the right time to learn and experience the richness, performance, and beauty of the web platform. Asynchronous APIs trigger an action to run in the background and notify you when it's complete. This pattern prevents your app from hanging if the action takes too long. This is one of the reasons that asynchronous APIs are used and are prevalent throughout the existing web platform and now in the new Windows runtime. For more information about asynchronous APIs, see session 203. Next, learn the best practices for writing fast and efficient Metro-style apps and sites. Master the basics by viewing session 162 and discover additional tips and tricks in session 386. Finally, limit your JavaScript execution on the UI thread. This is where web workers can help. Let's look a little closer at what happens on the UI thread. JavaScript code is started by user events, like those generated from moving the mouse or typing on the keyboard or touching the screen, or by timers or asynchronous callbacks. JavaScript code typically takes on one or two roles. One role is to update an app or site's internal logic, and the second role is to update the view by using document object model APIs. Those APIs in turn cause the app or site's layout to be recomputed. This process all happens on the UI thread, the app's primary thread. If you're unfamiliar with this execution flow or want to know more about how JavaScript, the basics of using JavaScript, please watch session 384. Note that while your JavaScript runs, it has exclusive control of the UI thread. Nothing else in the app can interrupt it, including user input. The main takeaway is that the less time spent running code on the UI thread, the more responsive your app can be. Web workers can reduce or eliminate the time JavaScript spends updating the logic in your app. Web workers are the only HTML5 feature that allows JavaScript to run at the same time as the code in the UI thread. This creates many new app and site scenarios. Imagine what your app could do if it could run JavaScript as long as needed without impacting the responsiveness of the user's experience. Before getting into specific scenarios, I want to establish a conceptual understanding of web workers and show how easy they are to use. Here's some key concepts to understand. While web workers might be considered JavaScript threads, they are more accurately compared to local JavaScript services. Think of web workers as an isolated JavaScript service running in a separate process. By running JavaScript in parallel, your app can more fully utilize the capability of modern multi-core processors. Web workers use the familiar event-driven model for communications. There is no tricky synchronization primitives to learn or worry about. In fact, there are no synchronization primitives such as mutexes or semaphores at all. So how do they work? Web workers have a runtime environment very similar to the one on the UI thread. When a web worker is created, it starts a new instance of the JavaScript engine. Its root object is a simplified version of the window object known as the worker global scope. The worker global scope is then initialized with the basic set of objects attached to the window, such as XML HTTP request, the location, the navigator, the new index database APIs, and WebSockets, etc. And that's it. Web workers don't have any presentation surface or window, and so most of the document object model APIs, including HTML elements and CSS objects, are not relevant and are not present. Creating and communicating with a web worker follows the same asynchronous programming model that you're already familiar with. In fact, if you're familiar with cross-document messaging, a web platform feature that allows iframes in different domains to communicate with each other, then you already know how to use web workers. Simply call new worker and provide the JavaScript file that you want to run inside of it. It's a best practice to always provide an error handler in case something goes wrong. Messages are delivered from the worker via message events, and the payload from the message is in the data property of the event. Use postMessage to asynchronously send messages to the worker, in this case a simple string, hello. On the inside of a worker, the code parallels what we've just seen. One difference is a new API called import scripts, which allows the web worker to load additional dependent JavaScript files before continuing execution. As before, a message event handler is assigned, and the data property of that event contains the payload. The post-message API is used to send messages back to the UI thread. Note that the messages are not required to be simple strings. In this case, an object with properties is sent. Finally, the web worker enters into a message loop, waiting to process new messages as they arrive by way of the message event handler. When web workers send and receive messages, those messages pass through a serialization and deserialization algorithm. That process intentionally limits the set of objects that can be sent and received. The set includes most JavaScript built-ins, including object and array. It also includes a limited set of DOM objects, such as canvas data, blob, and file objects. Similar to the JSON data format, sending JavaScript functions between web workers is not allowed. Now that you have a basic understanding of the key web worker concepts and have seen how easy they are to use, I will present 3 patterns that will give you ideas for using web workers to build responsive Metro-style apps and sites. The first pattern is to use web workers to execute the primary thread of your app. Second, to perform background processing. And third, to create asynchronous tasks. Traditionally, when you build an app or site on the web platform, the UI thread is the primary thread, and web workers are only helpers spun up to process some data on behalf of the UI thread. What if that traditional thinking were turned upside down? Imagine any scenario where the app's data model is sufficiently abstracted from the view that it could be contained within a web worker. One scenario that comes to mind is a drawing app, where the app's logic consists of the primitives and drawing state and all related logic for processing the data model. In this case, the app's primary thread is the web worker, and the UI thread can stay responsive by dispatching the user input to the web worker and then processing the view updates from it. This pattern helps apps improve their load time, since the bulk of the script resources required by the app's logic can be requested, parsed, and executed completely inside the web worker. This pattern encourages you to design apps using the model view controller architecture. The web worker contains the model, and the UI thread has the view and controller. Finally, from a security perspective, for apps that handle untrusted script, running such script in a web worker is a great way to sandbox that content. Recall that message passing serialization and deserialization algorithm will sanitize the messages so that they do not contain runnable code, which minimizes the potential risk. Many app scenarios call for periods of intense processing. If you need to perform image or audio processing, logic for a computer player in a game, gesture or face recognition algorithms, etc., then web workers are ideally suited for your scenario. In fact, it will be nearly impossible to build a responsive app without them. Background processing scenarios are typically long-running algorithms or frequently recurring, where one or more web workers are persisted or kept around in order to handle the requests. Web workers can continue executing long-running algorithms at full speed while sending progress notifications back to the UI thread at the same time. It's important to note that a web worker will not be interrupted by incoming messages. To process a message, a web worker first must yield control back to the message loop. On a related note, a new setImmediate API is useful for making the yield and resume programming pattern much more efficient. Web workers are also well suited for short-term usage scenarios. In this pattern, web workers keep your app responsive by encapsulating independent short-term tasks. For example, your app might need to periodically save its state to the local index database, or perhaps you're implementing a search box where you populate search suggestions based on what the user is currently typing. Each task is not dependent on the last, and each can run in parallel. For this pattern, package your code inside a web worker and then create them on demand. The fire and forget approach can be used when the web worker does not need to report back. The web platform will automatically clean it up when it no longer has any processing to complete. Web workers also provide the ideal infrastructure for creating your own asynchronous APIs. Your JavaScript code will run asynchronously and independently of the main UI thread, just as other built-in asynchronous APIs do. Web workers may not be the ideal solution for all scenarios. For example, consider a scenario that requires real-time UI updates. For example, a game that must maintain a constant 60 frames per second. The following guidelines will help you decide. Web workers do not provide any latency guarantees. They run as background threads and may be scheduled to run less often if the PC has many apps open at once. Do not depend on web workers for specific latency requirements in your app. Once created, don't assume that a web worker is immediately available for use. Messages sent to the web worker before it is initialized may be dropped. It is a best practice to have the web worker notify the UI thread when it has started versus assuming that it will start immediately. The web worker places limits, or the web platform places limits on the number of web workers that can be running at any one time. This means that there may be a delay before it starts up. Web workers can easily generate messages faster than the UI thread can consume them. Messages are not dropped while the web worker is alive. Therefore, the queue of outstanding messages can lead to a buildup of memory if you are not careful. Avoid using algorithms that produce more messages than necessary. Lastly, web workers do not have access to the document object, its HTML elements, style sheets, etc. If your scenario is heavily tied to these UI-related objects, web workers may not be suitable for your scenario. Customers will expect your Metro-style apps and sites to be responsive. Web workers provide the means to build powerful and responsive apps, and they are easy to learn. Web workers are available now, whether you're building a new Windows Metro-style app or updating an existing website that must run in any of the latest desktop browsers. Go build great responsive Windows Metro-style apps and sites using the web worker patterns that you've learned here. Thank you.